Okay. Now we do use ropes in merchant navy on ships for a variety of reasons. Once upon a time, we were heavily dependent on them because we had sailing ships. Sailing ships had lots of rope work. Everything was done with the standard ropes, like natural fiber ropes. Now, over a period, changes kept on coming in. Natural fiber ropes gave way to synthetic fibers because of advantages of them. Then in between, we also had wire ropes because certain jobs wire ropes could do, which natural fiber couldn't do. Then synthetic fibers, what we had, they could do certain jobs, but not replace exactly the wire ropes. So today also, we tie up ships with mooring ropes and all. Okay, we do have systems today with suction pads and all, but it will take some more time before ropes disappear. Means you are not going to disappear, make them disappear in next 20-25 years. They will drop down in number for all you know, but they will not disappear. And when I was cadet, our ships had derricks. So every derrick had like usual lifting tackle with the blocks and the wire rope. Then we had like if this is the one on sides, we had what we call guys. So there we had lazy guy. Lazy guy was wire. Then we had another piece of pendant of wire and then connected with a wooden blocks tackle. Those were guys. So you had to heave on them, swing it exactly where you want the derrick, tie them up first. So every derrick had, other than lifting gear, we had 1, 2, 3, 4, 2 wire pendants, 2 full wires, and then we had the wooden blocks and the purchase with it. So there was a lot of rope work. And that's why we had to learn all the tricks of the trade, like short splice, long splice, etc., etc. And to my what you say, bad luck or good luck? I'll say it is good luck actually. The third mate on my very first ship, he was a fresh third officer, but he was very very good with rope work and seamanship, and he ensured that never mind my sleep and all went for toss, but he wanted it all systematic. So in the bargain, you end up learning a lot. That's what happened to me, and then I have been very comfortable with it. Okay, now let me move this out of the way. This is a little bit out of the way. Okay, we make ropes. Now first we'll discuss ropes, not wire ropes, the normal ropes. They're made out of natural and synthetic fibers. Now what is natural fiber? It is one of the plants. Like we know in India, we also get coconut fiber rope. You'll find it. Means it was used for things. Over a period, now we have got more synthetic. But similarly, you had Manila, sisal, hemp, coir. Coir is that coconut one. Cotton, flax fibers and all. 1 minute, let me just take a few. Okay, so we had to make ropes from Manila, sisal, hemp, coir, and so on. Now, out of them, Manila was the friendliest one. Why? Because every fiber what you pick up from trees and all can be very rough, can have more thorny structures. A lot of stuff is there. So Manila was friendlier one, so it survived longest. Sisal hemp was used, but over a period there were issues with them. Like hemp and all can go in drugs. Cotton is very much used. Now, if you have seen the typical cotton flowers, it's a small thing. But yet, as you keep on pulling and you keep on weaving it into a thread, and from thread you have got khadi, and then you get all sorts of materials. stylish materials, everything. But what it means is from small fibers, you can weave it to make a long rope. Now, this is where the natural fibers like Manila and on were used in the beginning. They learned the trick how to make it longer because there is a limitation. Manila is not something like 100 meters long plant or something. So people learn how to extend it and keep on making it. Now, when you do it, when you're mixing up fibers, you are going to lose strength because holding on to each other with the friction. So it went on. Manila showed good resistance to things, so Manila became thin. But now what happens is they are never that strong. So as the time changed, like first they used to use loading was actually on the bags, were carried on the backs and dumped. That thing changed. Then they started using some sort of a derrick or a boom to lift it up. So now the weights increase. Now, when you increase the weight, you need a stronger rope to pick up. The stronger, how strong? Yes, you say, I want so strong, but what is the size of the rope? Size of the rope became fatter and fatter, so you can't handle it. So, that is where you got a next one. Then the synthetic fibers came in. Now, natural fibers had restriction on the length of the fiber, even though you could make ropes much longer than the average length of the fiber. But as you make it longer, it starts losing its strength also. Then, how do you make it? Simple. First, you twist fibers into yarns. From yarns, you twist it around to make strands. And from the strands, you make the rope. Now, if you twist this way, it will be right hand. If you twist this way, left hand, because one way or the other, you are twisting them around. So there will be one direction, clockwise or anti-clockwise. So the generally Manila ropes, what you are going to use on ships, will be always right hand lay. But you can have left hand lay. On average, you will have 3 strands, but you can have higher number of strands. There is nothing like a fixed rule, but what we use is generally 3-strand rope and right hand lay. Now, then there are ways and different ideas how to make it. Anyway, don't get too much into it because it becomes more interesting topic, but not required for you. Take it as a hobby. But that is how you make the rope. Now, this is the standard one. 3 strands, generally right hand lay, and normally you will find Manila. And cotton. Now, cotton rope, you can have this way and that way both. But generally the cotton rope, what you are going to see on the ship will be more or less without right hand lay or left hand lay. It will be like a multiple type of rope because they will be used for specific purpose. They are not stronger or something, but they have got water absorbability and also you use them for a specific use. Why isn't it going ahead? Okay, it moved. Now, so we had restrictions. And then what happens? It is organic material liable to get rotten with excessive water, and all these things were there. So later on, there was more and more research, and synthetic ropes entered. Something in 1960s, I will say. Even though in 60s there was very little use, and they were just entering on the ships. But basically in 70s we started seeing more and more. And then there are synthetic materials, means you got a endless choice. You design materials. Okay, nylon is general term. Polypropylene, polyester is general term. Terylene is there. Now the same materials were used to make your materials like garments. So the materials are strong. That is why they replace natural fiber ropes for many reasons, like they are lighter, they are stronger, then you need much smaller diameter. The strength is much more. They last longer. They have got better resistivity. They're easier to use on hands also. They are not rough for your hands. So over a period, they have taken over. And today the situation is such. I'm not looking at these types here, what is mentioned, nylon, polyester, and all. There are newer materials today where your a trouser belt size, just a belt size material can lift up something like 5 cars. That sort of a strength is available today. The materials are different, very strong, and it's just matter of time before they make entry, because first it goes in, scientists find it, then they hand it over to engineers, whether it's chemical engineer, mechanical, that's a different part. But then the engineers take over and try to make it commercial. So during that time, a lot of plus minuses will come in. It's not good for this, then they may change it. Now, especially here, what happens is, like, to find a material, a synthetic material, you get doctorate scholarships. Because you define first, I want material with density so much, thermal conductivity so much, electrical conductivity. You define it first. And then these guys who get this special scholarship, very bright guys, then they find that material, they make it, because it is like, it is not, one way it is in a sense it should be discovery, but it can call it invention also. Because they find out how to join carbons and oxygen and hydrogen and whatever, how to bond them and all. That is how it goes. So anyway, let's get back to our things. Like, for example, just get idea. Okay, rope sizes for breaking strain of 86 tons. This is what we are looking is like mooring rope. Okay. Nylon diameter is 72 millimeters. Polyester 80, polypropylene, the lighter material, is 88. Now, if you want Manila, the best Manila, 112 millimeters. So the rope is becoming fatter. So it will be almost impossible to handle. And if you take wire rope will be 48 millimeters. So the thinnest will be wire rope, but wire rope is heavy, whereas nylon is much lighter. So obviously, your preference will be nylon. Nylon is more expensive. So in the end, normally during my selling days, everybody settled down on polypropylene. Polypropylene, interestingly, there was like a tubular structures of every fiber. And when you produce these synthetic fibers, the length is unlimited. It is not restricted like natural fibers, that the plant has got so much of height, so you can't have longer than that. But in synthetic, it is unlimited. Now, what happens to resistance to various things what you are likely to face? Like if you get sulfuric acid, Manila, sisal, those are natural fiber. There is no resistance on them, means they will get destroyed straight away. Nylon is poor, polypropylene is very good. So over a period, generally polypropylene won the race. Okay. So these acids, rust remover is also a type of acid. It's a phosphoric acid. So when you look at it, just compare different chemicals, reactions and all. One way or the other, polypropylene wins, or polyester. But for certain qualities, polypropylene, because it is cheaper, so generally gets preferred. Otherwise, when you look at it, natural fiber has got its own issues with chemicals, because after all, they are living, they are made out of living cells. organic material. So there will be issues anyway. Okay. What is the advantage of synthetic rope? Superior lifting because strength is more. Strength to weight ratio, that is what we saw. The wire rope is strong, but wire rope is too heavy. So strength to weight ratios are good. They are flexible, planned, grips well without any problems. Electrically non-conductive, but of course if they are wet, with salt water, they will be conductive, but otherwise electrically non-conductive. Now, when used as a tagline, don't worry about it. We don't get so much inside it. Then they are safer than wire ropes because they are lighter. So handling it is also easier and cost efficient. That is, in the end, kitna chahiye paisa lagega. That is always the criteria for selection. Disadvantages, yes, there will be. For everything, advantages and disadvantages always come together. So there is not like only advantages there and there are no disadvantages. So next is normally ropes, because depending on how much you can handle, and along with the ropes you will also need the blocks, cargo blocks, or what you say, sheaves, the purchases and all. Then if the rope is going to be this thick, how big will be the sheave? This big. I can't even show you here. So if somewhere or the other you get restricted, and then you realize, okay, beyond this we cannot go. Then the disadvantage of the synthetic rope is it elongates a lot. It can stretch. So that creates a problem, because when you are hanging a load, when it touches down, then there will be a jerk, because what happens, first that extension is there, then suddenly that extension will go, that elongation. Then temperature has got effect. If temperatures go over 65 degrees, then there are issues. 1 minute. Let me send him off, because he doesn't like studies much. Go. Charge. Yeah. Okay. Since I have taken break, just give me a second. Okay. Now temperature has got effect. Now what happens? The synthetic materials generally have these issues with temperatures. You will notice it with most of the plastics. And then if the temperature exceeds 150 degrees, it will start melting. Like it will not happen to Manila. Manila is like made out of plant, just the way we look at the trees and all. They are stronger in that sense with the temperatures, because 65 degrees temperature and all is possible. So 150 is not going to melt. The wood is not going to melt at 150. It's not going to catch fire either normally. Okay, then let us get to the wire ropes, because I expect you to read more. We are doing revision. We are not trying to do the whole thing like we have done earlier. And lab has also given you good notes. Now what happens, since there was a restriction coming on synthetic ropes and you needed to lift up more and more loads, so wire ropes started getting in. So it is used for cargo gear, lifeboats, launching and pick up engine room crane or any cranes on the ship, we use wire ropes. Now, its steel wire rope has got three parts. It has got single individual wires. They are twisted into a strand, and there is a fiber rope or a synthetic fiber rope, a core, a heart, what we say, core or heart, and the strands are around it. Now, normally heart is made up of natural fiber. Generally, it is manila. Okay. Then, the purpose of that heart is simple. It absorbs lubricant, holds it there, because when you get these wires coming under the load, the strands, then they squeeze and then they get lubricated. Otherwise, you have got a problem with wire ropes, because individual wires, when they get under pressure and you're going to use them for lifting something, there will be friction, like wires rubbing against each other. So they will get heated up. And to make sure that heating drops down and the friction drops down, you need lubricant. Now, how will lubricant hold on? That is through the heart. Then, wire ropes is highly specialized branch. Though we don't get deep into it, it is a very complex thing. You use wire ropes to make bridges. You use wire ropes. So it is simple rule in wire ropes is, the higher the number of individual wires in a rope means more flexible it is. If there are lesser number of wires in each strand, means wire thickness will keep on changing. That is another issue. The lesser number of wires in each strand means it is stiff. Now, a lot of places you want stiff ropes. Wire ropes are flexible within limits. They will elongate little bit, but within limits. Whereas, like synthetic fiber rope will elongate a lot more. Natural fiber ropes will elongate little bit again, not too much. Why? Because after all, the trees, the wood and all doesn't elongate. There is a limitation of flexibility. Okay, sorry. I told you now I am doing two things at the same time. Now, always remember what we are talking about ropes is we stay within a limited thing what we use on the ships. We are not getting deep into like a rope science or rope engineering. We are not. So we have got simple thing as we look at it, natural fiber ropes, synthetic fiber ropes, two types. Then there are like natural fiber is manila, sisal, hemp. Synthetic will be nylon, terylene, polypropylene, polyethylene, polyester, and so on. Then you have got wire ropes. Wire ropes normally have got left-hand lay. Oh, no logical reason. It generally has left-hand lay because somebody started doing it and it remained like that. The way the railway systems in the world. First railway system started somewhere and everybody just took the same width of the railway tracks instead of redesigning and reinventing the wheels. So there is hardly any variation. Either you have got normal broad gauge and then you have got a meter gauge and then in case anything. Even though you can design whatever you want, but nobody wants to reinvent wheel all the time. So that is how we also use the ropes. Now, mooring ropes again have got different types. Synthetic fiber, but there are different types. Well, like certain ropes, the weaving is different. It is not like right hand or left hand. It's a different type of link. Now, coming back to our okay, like I have mentioned you, like construction of steel wire ropes, the lesser number of wires means it is more rigid. It doesn't bend easily. It's not flexible. The higher the number, flexible it becomes. So on ships, what generally we see is you will have any one of these 6 into 6 means 6 strands of 6 wires each in each strand. So 6 wires in each strand and total 6 strands. Now normal wire ropes, what we use on the ships are 6 strands. Then you have got another one. Now this is more flexible. 6 into 12. That means 12 wires in each strand and total 6 strands. 18, 19, 24. Normally on a ship we use 6 by 24. That is general purpose wire. Then we need some extra flexible one that is normally 6 into 36 or 6 into 37. That is generally used for lifeboat falls, or you also use it for quick closing valves. In engine room you have got quick closing valves to stop fire, means to stop the fuel. You close them from a remote position. So those wires are generally 6 into 37. Now, if you get any question on it, use 6 into 37 for lifeboat faults, because the higher number of wires, more flexible it is. Now, it can be this also, but use 6 into 37 that is traditionally used. Otherwise, sometimes what happens, the guy who is correcting papers may have a fixed opinion, and then there will be issues by reduction of marks. Okay. Now, anything that we use on board, okay, is always governed by planned maintenance. All wire ropes will be also coming under planned maintenance. Then there is a process. How do you clean them up? How do you lubricate them? When do you lubricate them? It all goes under planned maintenance. Internal lubrication is different than external lubrication of wires. Internal lubrication, you use oil with low surface tension. And what you do is, like, say this is the rope, like there will be sort of grooves, what you all have seen already. So first you have to clean them up with wire brush. Then you take sort of cotton waste soaked in oil and put it, and they sort of apply plenty of oil. So it goes inside. It goes inside. Why? Because in the middle you have got a natural fiber or synthetic fiber core. A purpose of that is to just absorb this lubrication and keep it. When the wire gets under tension, it oozes out and lubricates the wires. Wire means each individual wire and strands. So there is a friction. Whatever friction happens there, it gets two effects, like when there is a friction and you lubricate, there are two things. One is wear and tear that disappears, the friction drops down. Another one, it also removes certain amount of heat which is generated. So this is generally, if one question can come on this, only how does this lubricate? So now this is internal lubrication. Now when you are using wires at sea, wire ropes, we have got a bigger problem. What is our problem when we are using it? We are in sea water. We will be getting rain. There will be salt present. We will be getting bad weather. The sea water will be spraying all over. Now, galvanized wires, everything well said and done. The wire, the metal of the wire will start reacting to salt and corrosion will start. So you have got another type of lubricant, that is either it is what we say seawater resistant grease, or there is a cardium compound, or the more tar-like things. So when you lubricate wire, first you go through internal lubrication, then you coat the whole wire rope with something blackish looking tar-like thing. So that forms a protective layer outside, and it ensures that the salt will not come in contact with the metal of the wire for corrosion. And when it is going over the sheaves or wrapping on the drum, it gets a lubrication. Okay, so we move to the next part. These factors you have to know. Now every one of them has got different, but these factors give you approximately breaking stress. When we talk about breaking stress, remember one thing: safe working load is 1/6 of breaking stress. Okay, so if I had to find out safe working load, this formula you will be multiplying denominator by 6. But formulas are for breaking stress. Again, these formulas are approximation. In case you have got nothing, no information available, then you use this formula. Else, you always check a certificate that is issued along with the rope. Every rope coil, whether it's a manila, polypropylene, wire rope, anything, it comes with a certificate, test certificate, telling you what is the safe working load of it. That is the most reliable document for you. So same what we are looking at, flexible steel wire ropes. The steel wire ropes have a different formula. Don't worry about stud link chain because it's not in your syllabus. This is how cross section of wire rope looks like. There is a core in the middle here. Now see, like I told you, it's a different branch of engineering. Construction of wire ropes. Don't get too much in it, because what we use is some like this. Okay, core in the middle, all equal diameter wires, 6 strands, and the number of wires will change. Now this is 6 into 37. You want 6 into 24, just reduce the number of wires and make it 24 each. 24, 24, 24, 24. These are all special construction wires. There is also one type of wire which is non-twist one. Means it will not form the kinks when it runs out loud. Now that has got little different technology to create that wire rope. One common mistake, what happens when you are measuring diameter of wire rope? This is the right one to get the maximum. Now when you are going to use it to measure a working wire rope, you have to make sure you take couple of readings and then take the mean, because wire may not be in this perfect shape. It may be a little bit damaged here, there, so you have to make sure that you get the correct reading. This is the wrong one. Right? I didn't do anything. This is the wrong one. You see here, the maximum part. Here it is taking the minimum one. That is why it is wrong. Now, we just briefly touched it. These ropes. Actually, you have got some more to study. Here, I will give you idea here somewhere. Now see, for example, non-rotating wire ropes. This is all with you. These folders are with you. Okay, Now, when you read it, what happens basically is this: you are twisting wires in a particular direction. When the length becomes too big, when your cranes are hanging and your load is hanging, maybe almost 30 meters, 35 meters from the block, then these wires tend to get under the stress and start twisting around. That is why you need a non-rotating lay. Now, this is again a specialization, but here in basic principle, what happens is outer layer. If it is clockwise, then inner layer will be anti-clockwise. This is how they work out in perfect way, and they make it. When I was sailing, we used to get these wires, but they were not 100% successful, but they were better. Now, okay, here you get idea. See, the outer layer is this way, inner layer is that way, trying to neutralize each other. You should know in general what it is, because anyway, wires, what you get on ships, you are not going to decide. They come as spare parts. So spare part means the manufacturer sends you the correct one. Now this book, Best Seamanship Searchable, is a book which is very good book, and this is another very good book on seamanship. And these two are good ones I have taken from somebody. He is one Khan, but he is Cambodian guy. Even if you read this, good. Again and again we are going to talk the same things. Fiber. From fiber, what you make? Yarn. Here. From fibers you make yarns. From yarns are twisted to make a strand, and from strand you make rope. Same comparison. This comparison you must know. What is the advantage, disadvantage of synthetic fiber? But one way or the other, you are getting a full-fledged question here. I think there are two questions on rope work. So you can definitely be sure synthetic fiber, natural fiber, there will be one question, other one will be probably on wire ropes. So two questions. And interestingly, what happens is they have not put any calculations for you. So it will be always advantages, disadvantages, care and maintenance. Now care and maintenance, most of the things are common, only don't lose common sense. Like sometimes somebody, it will not be affected by this, that, like metal is not going to get affected by some sort of mildew. So, but if you start writing there, it looks bad. So just be very careful when you answer what it is. But care and maintenance is same, more or less, small differences. These braided ones you will get, different lays will be there. Now plated rope is what you will find for moorings. Plated ropes are generally mooring ropes. These are wire ropes, how wire ropes are made, SWR, steel wire ropes. Core heart, again we are looking at the same one. Now this is where important part comes. This is how do you store it? Here. Care maintenance. This is what you must do thoroughly. How do you store them? How do you open the coil? Like if you open the ordinary rope coil, the synthetic rope or a natural fiber one, you open it from inside. Otherwise, you have to use a turntable and then you pull it up and stretch it out. And Nikhil, what you wanted? Formulas you must know. Oi, Renai, I have given you all this. It is also there for sharing on Drive. There is enough material you all have got. You all keep on misplacing it. But search first. In the end, I'm quite sure it is on Google Share folder also. So you can go through that. Just stay relaxed and study. Don't get into panic mode. I don't have it. I don't know. No, relax. Everything is given. And in the end, worst situation comes, I can always give you again. Only thing is, I will not be able to send you as a file. I will put it on a drive, and from there I will give you a link. You download it. Okay. Now, this is the part which you have to do thoroughly. Because care and maintenance of fiber ropes and steel wire ropes. This is the standard thing for question answers. How do you inspect them? Causes of deterioration. How do you take care of it? How do you store them? Like you are supposed to wash them with fresh water. And safety. This. Avoid shock load, avoid kinks, avoid knotting. Remember, when you tie a knot on a rope, even on a single rope, if you tie a knot, you reduce the strength badly, as much as half the strength. So, knots, everything is not a good news. Splicing also same. Those are for convenience sake we do it, but they don't make it stronger. Now these things, this is what are general precautions, but they apply to all ropes as well as wires. Okay. We are coming towards the end of it. Go through this full, Just read once. That is going to give you a good idea what we are looking at. This is called flaking. This is flaking. What is whipping? You should be able to write on whipping. Like there are 3 types of common whipping. What is the purpose of whipping? To take care of the ends of the rope so they don't open up. The lace will not open up. And then there are 3 types at least you should be able to say. How do you coil? How do you uncoil? So all this is seamanship, but there are 20 marks in your paper on this seamanship. Seamanship Lab has also given you good notes. I have also put them on website as their notes. All the books tell you same thing. All books are prehistoric. Best Seamanship is a good book, and same the TJ House. And anywhere, it means you read, you are going to get the same thing. But these are the important. Care, maintenance is very important. That is where the questions are going to come. Now, this stuff and all this is wrong. Why? Because this is too loose. This is something, chains don't get into it. I will not recommend you getting into chains right now, because actually chains are not that definite, because nobody is going to ask you questions on chains. And if anything comes, you think of it as a wire rope. Handling, how do you handle the steel wire rope, because there are some wires can be broken. Chains are not normally used on ships. Very little chains will be used, but they are not used for lifting up things. Maybe sometimes for lashing, and otherwise, so this little cumbersome, and testing and all is quite expensive on chains. So already 20. So we will stop. Now you ask anything, doubts you have got. We got 75. Wow, I'm becoming popular. Okay, I will unmute you all so you all can talk. Okay, you're talking here. Not, I'm unmuting और mute all कहाँ से है? Allow participants to unmute. Earlier I used to get another one, unmute all करके. Now they removed it. So Moyuk, your connection has become all right. Correct? Because I am quite sure wherever you live in better off areas where people will take care of all these disconnections and all faster. We get some problem in Talegaon, but not that bad anyway. Hota hai. You all are better off than us. Any doubts now? Moyuk, even your case I have not seen ROR test. Huh? Start getting into ROR tests. You will realize someday that why I was telling you. Right now you will consider it a headache, but don't bother. Just take the test. Don't worry about the marks. Just after 5-6 tests, you will see the confidence level changing. Because what happens, the chota cheese, what you miss out. Like I was watching somebody's these marks. Small things, like for example, okay, you are on a man toe. What fog signal will you give? Now see, the confusion starts immediately. On a man toe, you give 1 prolonged and 3 short bursts to indicate this is a man toe. But this is where exactly I have seen lots of guys making this mistake. So this is why I want you to go through this ROR test. Chota points will get cleared up. And later on you will not have issues because your knowledge will be very thorough. And believe me, for your sponsorship and all, ROR questions are must. Okay, so chalo. Any doubts anybody has got? And one guy said no doubts. What about others? अलग अलग आवाज निकल. Okay. You can go now. Today is Saturday, so you want to go earlier also, no? Date will be there. You'll be. Chalo, bye.